In this topic, we discuss least common denominators. So let's start by recalling the technical definition of what a least common denominator is, and let's discuss how to find it. Definition: the least common denominator, denoted LCD, for a list of rational expressions, is the simplest expression that is a multiple of all the denominators in the list. For example, suppose we took the fractions 1/6 and we had the fraction 3/8 that we were trying to add it to. Now the two denominators are 6 and 8. And before we can add these fractions, we have to get a common denominator. So we'd be looking at the list of 6 and 8 and saying what would be the LCD for these two numbers, 6 and 8. Well, the LCD is by definition the smallest multiple, the least common multiple of 6 and 8. What's the least common multiple of 6 and 8, the smallest number they both divide into? Well, that's 24. 6 times 4 is 24. 8 times 3 is 24. So in this example, the least common denominator of 6 and 8 is 24. Sometimes when you have smaller numbers, it's easy, but once we start adding variables and larger numbers, it gets a little more complicated. So let's take a look at a process that you can always follow to find least common denominators, whether you have numbers or variable expressions. We begin by taking a look at how to find the LCD for 1/75 and 1/90. Since the least common denominator of 75 and 90 must be a multiple of both 75 and 90, it's tempting to just multiply the two numbers together and say that 6,750 is the least common denominator. It is a common denominator, but it's not the least common denominator. And often when you just multiply the numbers together to get your common denominator, it creates a lot of headaches later on because you have a lot to do to reduce. So let's talk about how to find the least common denominator for 75 and 90. To find the least common denominator, we must find the smallest possible multiple of 75 and 90. The easiest way to achieve this is to factor. So let's factor each denominator into prime factors. You may want to use a factor tree or however you like to do it, but you start by taking 75 and you work your way down to notice that it's equal to the prime factorization 3 times 5 times 5. 90 is equivalent to the factorization 2 times 3 times 3 times 5. So that's the first step. After you factor your denominator, the second step is you want to count your prime factors. Count how many times each prime factor appears in your factorization. So for 75, notice there's 1 3 and 2 5s. For 90, notice there's 1 2, 2 3s, and 1 5. Now, to find the LCD, you have to include the greatest number of any specific prime factor. Now, what does that mean? Okay, let's take a look first at your numbers. You have 2, a 3, and a 5. So looking at 75 and 90, and first considering the factor 2, you have 1 2, but 0 2s. The greatest number of 2s you have is 1 2, so you have to include 1 2. 3s. Here you have 1 3, but here you have 2 3s. Again, you have to take the greatest number of prime factors for any specific factor. So we have to take 2 3s. So that's 2 3s. Finally, let's look at the 5s. Here we have 2 5s versus 1 5. Well, the greatest number of 5s is 2 5s, and you need to include that. So the LCD will need 1 2, 2 3s, and 2 5s. Again, you take the greatest number of times that any single factor occurs in the two factorizations. So now, to get the LCD, we multiply the factors listed in the final column of our table. That's the number that will have all the factors of 75 and 90, but no extra factors. Therefore, it's called the LCD. Our LCD is 1 2, 2 3s, and 2 5s. And when you multiply them together, you notice you get 450, which is the least common denominator of 90 and 75. Let's take a look at another quick example. Find the LCD of 11 over 90 and 3 over 28. That is, we want to take a look at the denominators 90 and 28 and find the smallest multiple that both 90 and 28 divide into. We begin by factoring our denominators, 90 and 28, which we'll put in our first column. 90 factors as 2 times 3 times 3 times 5. And 28 factors as 2 times 2 times 7. Next, we want to count the prime factors that appear in each of the prime factorizations. In the prime factorization of 90, there is 1 2, 2 3s, and 1 5. While in the prime factorization of 28, there are 2 2s and 1 7. Now, to determine what's needed in the LCD, we want to look at each individual prime factor, that is 2, 3, 5, and 7, and take the most number of times it occurs in any single prime factorization. Let's start with the factor of 2. In the first factorization, there's 1 of them. In the second one, there's 2 of them. The most number of times it occurs in any single factorization is 2. So what's needed in the LCD is 2 2s. Next, we consider the 3s. There are 2 3s that occur in the factorization of 90 and no 3s that occur in the factorization of 28. So the most number of times the 3s occur in any single factorization is 2 times. That is, so far in our LCD, we have 2 2s and 2 3s. Next, we consider the number of 5s, and 90 is the only factorization that has any factors of 5. 90 has 1 factor of 5, so that's what's needed in our LCD. And finally, we take a look at the factors of 7. 7 only occurs in the factorization of 28, and it occurs 1 time. That means we need 1 7 in our LCD. This means our LCD is comprised of 2 2s, 2 3s, 1 5, and 1 7, which will multiply together. That is, our LCD is equal to 2 times 2, 2 2s, times 3 times 3, 2 3s, times 5, 1 5, times 7, 1 7. And that equals 1,260, which means our LCD of 90 and 28 is 1,260.